Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Thermohaline Circulation by Shintaro Fushida Hardy. And here are the rules. Standard Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Loop. Shade some cells to form a one-cell wide orthogonally connected loop. The loop may not touch itself orthogonally, but can touch itself diagonally. So orthogonally connected means that they have to be sharing an edge, right? And every single cell on the loop must be sharing an edge with two other cells on the loop. You can only share an edge with two other cells on the loop, which means that if you share an edge with three cells on the loop, that is not valid. And that's what it means by the loop may not touch itself orthogonally, but can touch itself diagonally. So for example, this is orthogonally connected, but this is diagonally connected because it's not touching itself. So therefore, this would not be a valid loop. This is not valid because it's not completely orthogonally connected. But this would be. And this is still valid because it's only touching itself diagonally. Now, if it were, say, like going this way into here, this would not be valid because it's now touching itself orthogonally in multiple ways, actually. This one is surrounded by 4 cells. This one's surrounded by 3 cells on the loop, which is not allowed. Anyways, that's how loops work. Non-loop cells, okay, let's go this. Non-loop cells form several orthogonally connected groups. Such a group of size n contains exactly the digits from 1 to n. Okay, so in this, so I think that's saying that so this would be a orthogonally connected group. This would obviously be, so this would be an orthogonally connected group. This would obviously be an orthogonally connected group. But oops, not that color. But I think it's also saying that all the stuff on the outside has to basically form an orthogonally connected group. So you can't, this loop does not work because specifically this is too large, right? This would all be considered one group. And each group must contain exactly the digits 1 to n. So this is a size 1, so this would be contain the digits 1 to 1. This is size 9, so therefore it would contain the digits from 1 to 9. And that's how non-loop cells form orthogonally connected groups. Okay. Thermosightline arrows. Each cell with an arrow, called an arrow cell, lies on the loop. So every one of these cells lies on the loop. A digit in an arrow cell is the number of visible loop cells in the indicated direction, where non-loop cells obstruct vision. Oh, interesting. The arrow cell is not included in this count. So additionally, digits increase along loop cells seen by an arrow, starting with a digit in the arrow cell. Oh, that's interesting. So each cell with an arrow in it, so all of these cells must lie on the loop. So they have to be on the loop. So that's another reason why this loop doesn't work. A digit in the arrow cell is the number of visible loop cells in the indicated direction, where non-loop cells obstruct vision. So, for example, okay, so say this is actually on the loop. This would then be 1 because it only sees one other digit on the loop because the arrow cell is not included on the count, right? Because it starts from the boundary, right? So therefore it goes, oh, how many cells do I see? I just see 1 that's on the loop. And digits increase along loop cells seen by the arrow, starting with the digit in the arrow cell. So the digit in the arrow cell is the lowest number then, and it must be continuously increasing from that cell, right? So this has to be greater than 1, which is fine. But let's actually use a better example. Maybe we have something like this. Okay, well, ignore that all the loop cells have to be, all the arrow cells have to be on the loop. But say we had this. This would see 2 cells, so therefore this would have to be a 2. This would have to be greater than 2 because it has to be continuously increasing. So let's say this could be a 5. And then this would have to be greater than that one because it's always continuously increasing. So it acts like a thermometer if you're familiar with the thermometer rule set. So therefore this could be like a 7 or whatever. And that would work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so let's color all the arrows green because we know they're all in the loop. So one thing is then that so it has to go this way because, well, okay, both of these have to go this way because that has to be at least 1. One of them has to contain this one and then go out because it cannot, if say you connected this complete thing, right? The problem is they would both see, well, okay, the problem is that you have to be continuously, or digits increasing along the loop cells. So if they connect, it has to increase all the way from here to here, but then it must increase all the way from here to here. Therefore, we know that it has to go in, one of them, okay, so say they both went out at this time. Well, first of all, this one can't go out because it would be touching itself orthogonally. So actually, we know that this one has to go in. Has to go that way. Well, okay, so then now it has to go this way at least. They both have to go out because again, like I said, if it all connects, this has to be continuously increasing from this direction, but it also must be continuously increasing in that direction, and that doesn't work. So both of these have to go out, and therefore this is not part of the loop. So this one sees 2 digits because it's blocked by non-loop cells. So this is 2, and this sees 1 digit. So this has to be continuously increasing from there. This must see at least 1, and this can't be part of the loop. It could go this way though, so that's fine. This one must be at least 2. Because it can't be, so this is 2 or 3, we're not sure which. So we know it goes that way. This one cannot be part of the loop. This one cannot be part of the loop, right? So this has to be greater than 1. This must be greater than 2. So this is 3, 4, 5, 6, 7, 8. This is 4, 5, 6, 7, 8, 9. This could be 3 through 9, so it's a lot. Okay, so this must be of size 6 at least. So whatever's here must be of size 6. This is 2 and 3. Oh, interesting. So this thing, what's the largest this group can be. Because remember, all non-loop cells form orthogonally connected groups, and they have to be of size n, which contains exactly digits 1 to n. Well, can it ever be 6 is the question. I guess no, not really. So it can't connect this way. So, okay, this is always sort of blocked in by this cell, right? Because you can't connect this way because that just forms a loop within itself, and then these can't be part of that loop. So if that's the case, this can only go that way for a certain amount. It can't ever go down, right? And then this has to go essentially out. Well, this can only go up to there, right? Because it can only go up to 7. And then this one has to go something like that, right? For that to work. But this cannot... I guess it could go that way. How does that work, though? If it goes... So say it connects to here. Say it does connect to here. The problem is... it cannot actually go back this way, because then this would be touching itself, right? To get out of this loop. So therefore, it would have to go essentially down. But the problem is that the region it forms is way too large. So this can never actually connect to this cell here. So this can be at most this way. But then it would have to go down if that's the case. Right? And then, yeah, then you have a problem. Well, I guess this one connects that way. That's fine-ish. Right? And then it could go, like, around here to, like, there. That's possible. Something along those lines. We know this is at least 3. Since this is at least 3, it has to contain at least 2 and 1. But the problem is, okay, so then the problem then becomes it needs a 1 in its group, right? You can only have 8 such groups. So you can only have 8 complete groups that are not in the loop, right? Because you need a 1 in each one of them. You need a 2 in each one of them, too. So there's only 8 groups max. Interesting. So this has to be 3 at least. And actually it has to be 4 because it needs a 1 somewhere, right? This could be 1. But if it's 1, that means this goes that way because it only sees one cell, right? So therefore this would have to go this way and then that way because it can't connect there. Therefore this would also have to be 1 because this is of size 1. So therefore it can't be 1 here. Therefore it has to see at least 3 then because this is at least 3. This can no longer be part of the loop. These two can't be part of the loop essentially. So therefore, this has to go at least this way. Because these two can't be part of the loop, because if it does part of the loop, then this cell would be next to 3 digits on the loop. So this has to go this way. This has to extend out, at least. But it could be something like that. No, because this one cannot go back this way. So this is not on the loop. Therefore, it must go this way, which means this must extend that way. So this is the large, so this is at least 1 through 4. So then this could be 2. Therefore, this one must go this way. Since that's the case, it cannot connect this way, so this is not on the loop. Therefore, this must go at least this way, which means this can't be 3. This is at least 4. So this is 4, 5, 6, 7, 8, right? It could contain all of those. This could go back this way. And then go something like this. Well, I guess it could connect that way. This is at least a region of 6. We're not sure how big it is, though. Oh, this must go out this way. Okay. So this, one of these 3 digits is a 2. Can this ever be, well, maybe. It could be something like that, I guess. That seems reasonable. Okay, but that doesn't work very well, right? How does this connect, essentially? It must connect either to this end or to this end, right? Or to this end, right? Well, this could go this way, in which case this would have to be 1, 2, 3, and 4. So this could not be 3 or 4 then, if that's the case. Then this would be 1, 2, 3, 4. So that would be 1, this would be 2, that would be 3 or 4, and this would be 3 or 4. This would have to be 2 if that's the case. This is always increasing, so this is 3, 4, 5, no 6, 7, 8. This is 4, 5, 6, no 7, 8, 9. Can this be larger? I guess it could do something like this. No. So this side can never connect to here, right? Because if it does, this side always has to get here, and then it must connect to here, and then therefore this forms 2 loops, which is not allowed. So this one can never actually get all, it cannot connect to this. Can it connect to here? No, because then that blocks this. So it can't connect to either one of these 2. It must connect somehow down, right? But it could go do some, well, can't really do that. So say it went up. It would have to go down. It could not connect this way again. right? Because if it connects that way, then this forms one large loop here, but then this has to form a separate loop. So this cannot go up, right? If it goes up, it can't go back down because this attaches itself and this one connects to that loop, which we've shown that doesn't work. So therefore, this is not on the loop. It must go this way. Again, it can't go up because it connects that way then, so this can't be part of the loop. This has to be part of the loop, and then it must go down because it cannot connect to this part. Therefore, these are not part of the loop. Therefore, this is 1 through 4. Obviously, none of these could be 1, so this must be 1, which makes this 2, and this is 3 or 4. This is 3 or 4. So this can't be 2. This is 5 or greater, 5, 6, 7, 8, 9. This obviously can't be 4, because if it's 4, then that forces this to be 3, and that eliminates all possibilities for this cell. So these are all 5, 6, 7, 8, 9. Obviously no 6 here. So it connects this way, then connects this way. Now the question is, how does this break this way, right? This must somehow go this way, which means this one goes this way. So how does this form a group here, right? The only way it can form a group is it goes that way, right? Because otherwise, if it tries to do this, say it went this way, I guess it could go like that, maybe. And this would be 1 through 9. Okay, so that is possible. But then you need to break out. Okay, so the problem is if it goes this way, it has to go here to block off this to form a group, right? Therefore, it cannot go. It would have to go this way. It can never go actually this way, right? So say we tried to do this. This forms a fine loop, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that could have the digits 1 through 9. But the problem is this is a loop. Or sorry, this is a group, and it's already greater than 9, right? This has to be at least 10. So that does not work. So it must somehow close this off, and therefore if it tries to do this, this adds up to 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore you can't have 10 digits from there. Therefore, it cannot go this way. It must go this way to close this off. And therefore, this is part of another loop. So it must go then this way. This can't be part of the loop. This is 1 through 4. So this is 1, 2, 3, 4. Obviously, there's no 2 here. There's no 1 here. So this can't be 3 or 4, which means this can't be 5 since it's always increasing. This sees exactly 4, right? Because it sees 4 cells and it's now blocked by that. So this can't be 4. This is 1 or 3. This can't be 3 then because we have a 1, 3, 1, 3 pair, which eliminates 1 and 3 in these possibilities. So this is 4 now. This must be always increasing, so this is at least 5, 6, 7, or 8. So therefore this is 8 or 9, this is 7 or 8, this is 6 or 7, and this is 5 or 6. Since this is 5 or 6, if this were 6, this would have to be 5, and that would eliminate all possibilities for this cell. So this can't be 6 then anymore. This has to be 7, 8, 9. The rest of this box must contain 5, 6, 7, 8, and 9 because we have a 1, 2, 3, 4 accounted for in 4 cells. So this is 5, 6, 7, 8, 9. Obviously, this can't be 6. Okay. Okay. So one thing this cannot do then is go all the way here. Because if it goes all the way here, that would mean there's no place for 2 in this non-loop cell. And you need to have the digits 1 to n. And this is at least 3, right? If that's the case. I guess it could go down here. but then it can't go exit out, right? So that doesn't work. Therefore, we know it cannot go this way. It can't go here and then down. So this one, it cannot go this way then at all, right? If it tries to go here, I guess it could, no, it could go up. Yeah, it could go up. So this one's fine, but we know this can't be part of a loop. We know this can't be part of the loop. And it could go this way and go up, or it could go here and go whatever. So this one cannot be part of the loop, but we don't know about this, right? So this has to contain a 1 and a 3. We know there's already 4, so it must be at least size 5. But we don't know if it's more than that, right? It could be more than that. What's the largest this could be? 1, 2, 3. What? It would have to connect. So what happens if it connects this way? I guess it could go something like that. This is possible. Yeah, that is possible. How does this close off, right? Say it tries to go here, then inside here. That doesn't work, right? Because it would be touching itself here. Because this would be orthogonally connected to 3 cells on the loop. So this one cannot go this way. It has to essentially go this way at best, right? So therefore, it must go at least here, which means these aren't on the loop, and this is not on the loop. This is no longer, similarly, this can't go this way. So this, to form a region that is, that can contain the digits 1 through n, it has to be specifically this one. So therefore, it has to be here, which means this has to be part of the loop, which means it must go down here. This cannot be part of the loop then. This must go this way. This is the digits 1 through 9 in this loop. Or sorry, in this group. In this non-loop region. We have one group here, 2, 3. So this already has 6 in it, right? It can have at most 3 more. But it could just be like that. That's possible. We do know it goes here, though. This must go here. Obviously, this can't be part of the loop anymore. So this is at least 1 through 5. So the rest of row 6 must be 5 through 9. This can't be 6. This can't be 7. This can't be 2 or 4. So what could this be? This could be 1 or 3. 1, 3, 5, 6, 7, 8, 9. What we know is to connect here, this would have to be at most a region of size 8. So none of these can be 9. They have to be at most 8. Okay. This is either 4 or 5. Oh, but if we tried to make this 4, the problem is where are the 2 and the 4? They both have to be in this cell. So this cannot be, this has to be a region of size at least 5. So it could go here. So this does not work, because then this region doesn't work as a region, because it can't contain 1 through 4. Because this would have to be 2 and 4, so that doesn't work. So this one cannot go this way. Or I guess it could go that way, though. And this could be 5. So this is at most, now, this region must contain the digits at most 1 through 7. So these can't be 8 then. This can't be 8. This is 1, 2, 3, 4, 5, 6, 7 at most. This can't be 6. This can't be 7. This can't be 1. So, and we know this is 3 actually, because this sees 3 digits, and it has to be continuously increasing. So this is 4, 5, 7. This is now 5, 6, and 8. This is 6, 7, 8, and 9. So we know the 2 has to be one of these two cells. Because where else can it be in row 4? Can't be any of these. Can't be these two because the 2 is here. Therefore, this can't be 2. Therefore, the 2 is one of these 3 cells, and the 1 is one of these 3 cells. Okay, whatever this has, it has to have a 2, right? So it could be something like this, in which case this would be all 2. Or it could be something like this, in which case one of these is 2. Or it could be something like this, in which case one of those is... neither of these can be 2. So there has to be at least... Oh, it can't be 4 either. Where are the 2 and 4 in this region, in this non-loop region? Can't be here, can't be here. It has to be in one of these, it has to be both of these two. So this has to be 2 and 4 specifically. Which means this is green, and these are green. So now this is a region of 5, so it must be the digits 1 through 5. Therefore, this must be 5. This can't be 3 or 5 or 1 or 2, so this must be 4. This can't be 3. Therefore, this must be, it can't be 5, 6, or 7, so it must be 1, which makes this a 2, 3 pair. So this is 2 and 3. This can't be 2. Where's the 1 in this row? It has to be here now. So this is 1. So this can no longer be 1. And therefore, now, now this limits us in regions to 7 at most, right? Now we have 1, 2, 3, 4, 5, and 6 regions right now. So there could be a 7th one here. But obviously it can't be just that, because this can't be 1. So it could be something along the lines of, oh, how does this form a region? Okay, so this has to be not part of the region. Therefore, this has to be the digits 1 through 7. So this is 5, 6, or 7. And this is 5, 6, or 7. These has to be 8 and 9 specifically. So this can't be 8 or 9. None of these could be 5. Therefore, by the process of elimination, this must be a 7. Because we have an 8, 9, 8, 9 pair here. So this can't be 8 or 9. Can't be 5. Can't be 6 because of this 6. So therefore, that's those possibilities. So this can't be 6 or 7. This is 1, 3, or 5. This can't be 7. This can't be 5 or 7. So this is 6, 8, or 9. These are 6, 8, or 9. Where's the 4 in box 6? Cannot be any of these. Cannot be any of these. Can't be any of these. Therefore, this must be a 4. So this is 4. 2 is one of these two. This can't be 7 anymore. Therefore, we have a 6, 8, 9 triplet in box 6. Therefore, the rest of the box cannot, cells in the box cannot contain 6 or 8. So they're 8, 6, 8, or 9. So therefore, this must be 5. So these can't be 5. This must be at least size 7 non-loop cells. So therefore, you have to have at least 7. Well, it could go here and then go here. That's possible. It cannot go this way and this not be part of that group. Therefore, this is always not part of the loop, right? Because if it tried to be part of the loop and this was not part of the loop, that just doesn't work because it enters in but it can't exit out. Therefore, this is always part of the loop, or not part of the loop. So what happens? Okay. This cannot just continue on and go here, right? Because then this is too large. So there always has to be a non-loop group that's separate from this one, right? Because it can't double back on itself. Can't and touch it. It would touch itself this way if it went down and then up. So it can only get at most 1, 2, 3, 4, 5 cells in the box on the loop, right? Therefore, we have left over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different non-loop cells. Therefore, it has to form two groups. And this could be 9 at most. So therefore, this has to be at least 4 in this area. Obviously, this cannot be part of the loop because if it were, it has to connect this way. And this one can't connect this way because it can't connect over here because this would be touching itself. So this one has to go at most this way. But then this would be 10 at least if that's the case. So if it goes up, it cannot go back down. It would have to continue going this way. And there would have to be this region. I guess this could work. Hold up. Yeah, this is 1, 2, 3. I guess it's 12. Yeah, it's 12 instead. Yeah. I counted kind of wrong, so it's 12. So it could actually go this way, and this would be 9, right? This cannot be 2, 1, 2, 3, or 4, or 5. This is 6, 7, 8, 9. Now we have a 6, 7, 8, 9 triplet in box 8. So the rest of the box cannot contain 6, 7, 8, 9. It couldn't already contain 2 or 4. Therefore, this is 3 and 5, which means 5 cannot be here because we have a 3, 5, 3, 5 pair here. We also have a 7, 8, 9 triplet in row 7, so the rest of the row cannot contain 7, 8, or 9. Therefore, this is 6, which forces this to be 5. So 5 can't be here. This must contain 1 of 6 or 7. This is 1 of 6 or 7. Therefore, the rest of the row cannot be contained 6 or 7. Therefore, this is 8 and this is 9, which means this can't be 8 or 9. We have a 5, 6, 7 triplet now in row 8. The rest of the row cannot contain 5, 6, or 7. Therefore, this must be 8, which makes this a 9 because this has to be greater than that. This can't be 8 or 9. This can't be 8 or 9, so this is 7. This can't be 8 or 9, so this is 8, which makes that 9. This is 2, 6, 7, or 8. 2, 6, 7, or 8. This obviously can't be 6. This can't be 6. This can't be 7. And this can't be 2. Okay. We know this region here has to be at least of size 2. But the problem is then it requires a 2 to be in its region. Or in its group. Therefore, this has to be part of the group. And therefore, it must go this way. We also know it needs a 1. Where's the 1? Well, it can't be... So therefore, this is part of the loop. It must go here. This could be not part of the loop, but then that would form a region that's only 5 large. So therefore, and this would not be part of that group because it's not from 1 to 5. So therefore, this must be part of the loop. This must be... Where's the 1 in this group? It can't be either of these, so it must be here. So this must be 1, which makes this a 3, which makes this a 1. So one of these is part of the loop and one is not. This is not part of the loop. So this can never be 1. Where is the 1 then? It has to be one of these two cells. This could be 3 or 4. Therefore, if this were not part of the loop, sorry, if this were a non-loop cell, it would also have to be 3 and 4. because we need the digits 1 through 4 in the 4 size group. But the problem is it can't be 3, 4 because of the 3, 4, 3, 4 pair in column 1. So this cannot be part of the loops. Or sorry, it cannot be not loop. It cannot be a non-loop. Therefore, this has to be part of the loop, which makes this not a loop. So we have the full loop. This must be 3 because it has to be 1 through 3 in a non-loop group. Therefore, this is 4, and this is 3. That's 3 in the corner. We celebrate. This can't be 6 in either of these cells, whereas a 6 in column 1, it must be here. So these can't be 6. This can't be 5 either. We have a 7, 8, and 9 triplet in box 4, which eliminates 7, 8, and 9 in the rest of the box. So therefore, this is 5. This can't be 7 anymore. This is 8 or 9. This is 8 or 9. This has the digits from 1 through 9 in this region. This has to be 8, 9. This is 8, 9. That eliminates, we have an 8, 9, 8, 9 pair in this region, which must have the digits 1 through 9 once each. So therefore, you cannot have an 8 and 9 in the rest of the region. So this must not be 8 or 9. This has to be 7, which means this can't be 7. This is 8 or 9. This has to be 5 and 7 specifically, and we have 4, 8, and 9 here. Again, this can't have an 8 or 9 because there cannot be an 8 and 9 in the rest of the region because of the 8 and 9 pair. Therefore, this is 4. This can't be 8 or 9. This just has to be 8 or 9 here. This can't be 2. Sorry, this can't contain an 8 or a 9 either. What can it contain? It has to be 1. It can't be 1, 3, 4, 5, or 7. So this has to be 2 and 6 specifically. So this is 2 and 6. What's in the rest of the region? It must be 1, 3, and 5. So this is 1, and we have 3 and 5 also possible. Now, this is 2 and 6, which means we have a 2, 6 pair in box 5. The rest of the box cannot contain 2s or 6s, so this can't be 6. This is 8 or 9, which forces the 6 in row 6 to be in box 6. So therefore, this can't be a 6. This is 8 or 9. This has to be 7 with 8 or 9. And obviously, this can't be 8. So therefore, this is a 9. This can't be 8 or 9. Therefore, this is a 7. This can't be 7 or 9. So this must be 8, which makes this a 9. Which makes that 8, which makes that 9, which makes that 8, which makes that 9. Neither of these could be 9. What is the last cell here? This cannot be 2. It could be 4 or 6, though. Cannot be part of 1, 3, 5 because we have a 1, 3, 5 triplet, and it obviously can't be 7, 8, or 9. Okay. This can't be 1, 3, or 5 because of the 1, 3 triplet in box 2. It cannot be 2 because we know the 2 has to be one of these two. So it could be 4. Well, okay, where's the 9? The 9 could be one of those two. So this could be 9. It could be 4. It can't be... This one can't be 5. This can't be 6, 7, or 8, but this could be 6 or 7. So we have that. What is this cell? Okay, so 7's one of... Okay, this can't be 7 because of this 7. Therefore, that forces this to be 5, which makes this 7. So this can no longer be 5. What else are we missing? We have here, we need 1, 2, 3, and 5. This can't be 5. Where's the 5 in column 7? Can't be here, can't be here, can't be here, so it must be here. So this is the 5. Therefore, this is 1, 2, or 3. Let's see. What else do we have? This cannot be 7. One of these two is 7. That's fine. One of these is 5. This can't be 5 anymore because of this 5. So this must be 6, which makes this 7. Makes this 6. So none of these can be 6 either. Where's the 5? Well, actually, we have a 1, 3, 1, 3 pair in box 9. The rest of the box cannot contain 1 or 3. Therefore, that's a 7. This is a 5. Okay. We have 1, 2, 3. This can't be 6 anymore, therefore this is an 8, which makes that 6. Where is 9 in column 8? Can't be any of these because of these 9s. Can't be here because of that 9. Can't be here because it's a 7. Therefore, this is a 9, which means this cannot be 9. Where's the 9 in box 2? The only possibility now is this cell. So therefore, that's a 9. This can't be 8, so this must be a 2, which means this can't be 2. So this can't be 2. We have, what's the last digit there? It has to, in row 2, it has to be 4. So that's a 4, which makes this a 2, which makes that a 4. We have a 1, 3, 1, 3 pair in column 7, which eliminates 1 and 3 from the rest of the column, which makes that 2, which makes that 3. This can no longer be a 3. Therefore, this must be a 1, which makes that a 3, which makes that a 1, which makes that a 3. This can no longer be 3, so this is 5. This can't be 3 or 5, so this is 1. So this can't be 7. This can't be 7. This must be 8. This can't be 7 or 8, so this must be 6, which means this can't be 6, so this must be 4. This can't be 4 or 6, so this must be 7. That 4 eliminates this 4, so this is a 2, this is a 4. This is a 6, this is a 2. This must be 5 and 3. Now we're looking for the last 2. That must be here. This must be 3. No 3 in the corner, but this is an 8. And that's the solution. Pretty cool puzzle. I like the way that everything's so sort of interacted. Nice logic here. Yeah, developing the loop was very interesting because of the limitations that you had. And it was pretty fun. Anyways, I hope you had a fun time watching this solve, and I'll see you next time on Frank Puzzles. Take care.